Let's now do a couple of problems where we solve these equations by using what we call substitution. Now, in this chapter, we're working with quadratic equations. So this is a case where you look at this first problem written up here, x to the fourth minus 5x squared plus 4 equals 0. That is not a quadratic equation. A quadratic equation is when you have the variable squared, and then you can also have the variable to the first power, but that's it. X to the fourth is not a quadratic equation. However, the reason these problems are called substitution is we can do a substitution, and after we do the substitution, then it turns out that the equation will be turned into a quadratic equation. So we went over this in class, so let me just work through these two problems. It's always the same. We're going to use the variable u, and in this case you always take the variable part of the middle term. So in this case, the middle term is this negative 5x squared. The variable part is x squared, and that's what I'm going to call u. And then for me, the way I like to do it, just to keep it clear, I go ahead and then square both sides of this, so they get u squared equals x to the fourth. And at this point, if I go back into my original equation, and every place I have an x, substitute it with a u, or not just u, but the equivalent in terms of u, then I get this. Notice x to the fourth, I'm saying here, is the same as u squared. Minus 5x squared, x squared I'm saying is the same as u, plus 4, there's no variables in that term. So now, whoops, I forgot my 5 here. Minus 5x squared, so minus 5u. So now I've gone from an equation with x's in it that was not quadratic. When I've done this substitution, all of a sudden I have a quadratic equation with respect to u. So I can now solve this equation for u. And as it turns out, this equation factors into minus 4 and minus 1. So really, when I factor it, u minus 4 times u minus 1 equals 0. So I have two solutions, 4 and 1. Now it sort of feels like you've solved the problem. But you know what? If you look back at the beginning, I have an equation with x's in it. If I'm trying to solve this equation, I'm trying to figure out what does x equal. Well, what I've done so far is I've solved for u. But if someone gave me this problem and I gave them the answer u equals 4 and 1, they're going to say, what is u? I'm wanting to solve for x. So now what we have to do is we have to switch from u back to x. So it's almost like what happens is the problem begins with x's, we do the substitution and solve it, and we get u's, and now we have to convert from u's back to x's. Then we are in fact done. And the way we convert back is we go back to where we originally defined what u is going to be. We said u equals x squared. So what I'm going to do now is I'm going to take my first solution for u. I'm going to take 4. Now I'm going to plug it in for the u right here. And now I'm going to solve this equation for x. 4 equals x squared. If I want to solve that for x, what would I do? Well, I take the square root of both sides. So when you do that, you actually end up with two solutions, because you have to remember, when you take the square root of 4, it can either be 2 or minus 2. So now I get the solution x equals plus or minus 2. Those are, in fact, solutions to my original equation. If I go and plugged in 2 for x, it would work. If I plugged in -2, it would work. But this is just half the problem. This is just for when u equals 4. How about when u equals 1? Then I can say 1 equals x squared. And I take the square root of both sides. And I get x equals plus or minus 1. So in a sense, this equation has 4 solutions. +1, -1, +2, -2. Now let's look at a second problem of using substitution. At first it looks even a little uglier. Look at this one. X to the 2/3 power plus 3x to the 1/3 minus 10 equals 0. Once again, if you look at that problem right there, that is not a quadratic equation. If we just left the equation like that, we don't have the means to solve it in that current form. However, as it turns out, this is the kind of problem we can do substitution on. So once again, you take the variable part of the middle term, which is x to the 1/3, and that's what we call u. And then what I like to do is I go ahead and square both sides of that. So I get u squared equals, now what is x to the 1/3 squared? Well, in that case you would multiply, so it's x to the 1/3 squared. And what's the power rule say? You multiply these exponents. So u squared would be x to the 2/3. Now I go back into my original equation, and instead of having x's, I put in u's. So I have u squared, x to the 2/3 equals u squared, plus 3 times x to the 3rd is u, minus 10 equals 0. Now, lo and behold, I have a quadratic equation. And I believe this one factors. So when I factor it, I get u plus 5 times u minus 2 equals 0. So my solutions with respect to u are minus 5 and 2. But once again, I'm not trying to solve for u, I'm trying to solve for x. So now the last step is to take these solutions for u and convert them back to x. So I go to my original definition. U equals x to the 1/3. Let's take the 2 first. So I plug in 2 for u. And now I need to solve for x. So 2 equals x to the 1/3. So from that equation, how would you solve for x? Well, if you've got x to the 1/3, I want to somehow convert it to x, and I can do that by cubing it. So if I cube both sides of this equation, 2 cubed is 8, 2 times 2 times 2, I'd have 8 equals x. Now I go back and get my u equals minus 5, and I have minus 5 equals x to the 1/3. And I do the same thing. I'm going to cube both sides. And when you do that, you have x equals negative 125. And those are, in fact, the 2 solutions. So these are called solving by substitution. The equation initially is not a quadratic equation, but by doing a proper substitution, you can turn it into a quadratic equation which you can then solve, and then you can convert it back to your original variables.